That's why I thought it was in here. All right, so welcome to C++. What is C++? It's a programming language, right? It's a programming language based, or it's an expansion of the programming language C, which was invented in 1970. C++ was invented during the 80s. And, oh, that's old. No, not really. It's been continually updated since then, and it served as a template for a whole bunch of other programming languages like Java, JavaScript, C#, all sorts of other languages adopted the conventions of C and C++ in their syntax, using curly braces here and parentheses there, stuff like that. So it is a very good thing to learn because it is incredibly widely used in programming industries. You know, just about every video game you see will have been written in C++ because it compiles to an executable rather than running as an interpreted file. If you've done Java programming or you've done Python, when you ran it, what happened was it was being interpreted on the fly by your computer, meaning that it was reading in something and then it was converting it to machine language instructions for your specific, operating system and stuff like that. But that's not the same thing as an exe file. An exe file is the zeros and the ones that the operating system and the processor need to run. So it's already being compiled. It's already running a .exe. You don't ship the customer the source code. The source code for Call of Duty probably fills up, terabytes of, hard drive space or something like that. Instead, you give them an executable to run, and it runs very quickly. If you program it correctly, the only way you could write something that would run any faster is if you wrote it in pure machine language, assembler, something like that. Now, maybe smudging, truth a little bit here and there, but that's pretty much the case. Okay, so you're here. You know what room we're meeting in. Now I do too. It's going to be in this room, guys. So, prerequisite, I do not know why it says that you have to have taken Java first. That's pretty bizarre. Okay. My office is wrong. Okay, for Pete's sake. I don't know why my Google Drive is not syncing. I'm downstairs in room 102. I have office hours Monday, Tuesday, and Wednesday. If you need to see me, I'll make an appointment with you to come in Thursday or Friday. No problem. Happy to do it. I don't live far away. Better yet still is if you text me, I respond very quickly. And I stay up until like 3 a.m. every night, so you don't have to worry about waking me up. And I do know how to silence my phone. So what typically students do is when they get in trouble in one of my classes, if you get stuck on a programming problem, you just snap a picture of your source code, right? And then you send it to me. And I go, oh, I may be able to tell you immediately, go to line 19 and add a semicolon, right? Or I may need you to take a picture of the error itself, in which case you take another picture and you text it to me. Like usually within 5 minutes, we can get the thing resolved, rather than you emailing your project and me having to be at a desktop computer or laptop or whatever. I can be doing this stuff with my phone and help y'all. So students who take advantage of that usually do pretty well in the class. Usually I know that it doesn't mean that you're dumb if you're asking me questions. You're smart. Smart for taking advantage of the resources available to you. So with that in mind, what I'd like for everybody to do, and even you guys who are already in the class, please do this as well. Been with me in a previous class, and so you think I have the phone number. Go ahead and send me a text message with your name, please. Add me to your phone book, your contacts, so that you can text me. Phone calls are great too, but honestly, I don't always have my phone on me. I always have my iPad on me. So, text messages I check even more often than I check voicemail. I will never communicate with you over anything besides school-related matters. I will probably never text you out of the blue unless it's just to say class is canceled or, check out the bad weather. I don't blame you for not coming in, that kind of thing, right? Or, I got hit by a train on the way here, so, you might want to skip coming in, that kind of thing. Strongly recommend you take advantage of it. Okay, so you're going to need a textbook, starting out with C++ from control structures to objects, 8th edition. Well, it's actually up to the 9th edition. If you want to buy the 8th edition because it's dirt cheap, that's fine. But you're going to make sure you want to get it quickly, right? Because this is an 8-week class. We have to be rolling pretty quickly. I just buy my textbooks on Kindle, right? So that I can, but there's a problem with getting electronic textbooks. For one thing, people remember stuff more, supposedly, if they're holding a physical textbook, but too bad, I buy them electronically. But when you're in my class, you get to use the text during exams. But if you had to take the exam, if you had to miss a day and go take it at the Learning Resource Center, they don't let you do, electronic textbooks. You can't pull out your Kindle or your iPad or whatever. So that's the only thing to consider. If you're not going to miss the exam dates and you want to have the book electronically, then you can get it instantaneously. Just make sure you get it quickly. All right, so you're going to need a home computer or a laptop capable of supporting C++. And when I say need, it's really advantageous to you because you're going to be doing your homework in that environment. What are your choices if you don't have a computer capable of running it? And that sounds silly, but I've had students, want to do the class on their Chromebook or on an iPad or stuff like that. And yeah, you actually can write some C++ code on an iPad or on a Chromebook or something like that, but not. If that's the case, if you're using that kind of tool instead, you're probably going to want to come up to campus and use the computers in this building. I do not know if the computers in the library have Visual Studio, the C++ programming environment we use there. But the ones in the room next to us, that little business lab, absolutely do. You don't have to use Visual Studio. There are other C++ environments out there. If you're a Mac user, then your Mac came installed with one. And if it didn't, then you can download it from the App Store for free, and it's called Xcode. Works great. It's a great compiler. Vast numbers of people use it, to write iPad, iPhone software, if nothing else. So if you're using Linux, I am assuming that you're a guru enough to know how to find a C++ compiler for it. You don't have to use Visual Studio, but it's free. It's available to you. You may as well use it, in my opinion. It's like the industry standard C++ development environment, and you can do a lot of other development other than just C++ on it as well. If you took a Java course from me, then just like we use NetBeans, we use Visual Studio. Okay, so we use D2L. Is this the first semester for any of y'all here? Everybody knows how to use D2L? Good, we can shorten some of our lectures there. Alrighty. We should understand the fundamental concepts and general principles of programming by the time we're done. And if you've taken fundamentals of programming, then you're already, a step up. And some of y'all are professional programmers, and you may find this course boring, in which case I strongly recommend that you try to do extra work outside of what I'm assigning. If I assign something, then you can get it done in 5 minutes. Figure out how you can do extra stuff with it. Go ahead and use it as a learning experience. Write programs, and if you're a professional C++ developer, you shouldn't even be in the class, right? I mean, talk to me if that's the case. If you've written code professionally for C++, yeah, there's probably things I can teach you, but you're going to be falling asleep. But if you need credit, whatever, right? You can judge what you need. Write programs utilizing logic constructs, selection, and repetition. How to use a C++ debugger to figure out what your program is doing. We didn't do that in fundamentals, right? Or at least not very much. We didn't pop open a debugger and step through it line by line until we found the line of code, right? Or watch the program run and watch the variables change. But you can do that with Visual Studio. NetBeans had that ability, but I don't think that we focused enough on it. I'm going to be trying to focus more on it. And then using language features such as arrays and abstract data types. If you've done Java programming, those terms are going to seem kind of familiar. If you've done Python programmer, just whenever you see the word arrays, think lists, as they are similar but not identical. Grade scale is pretty boring. 90% above is an A, 80% is a B. Do I curve? Not really. If you're making an 89.5, am I going to give you an A? Yeah, probably. If everybody in the class was making a B and a C and nobody made any A's, would I find a way to bump grades up, slide grades? Yeah, but I don't usually have to do that because usually the majority of people in the class are going to make will make A's. That's just my experience. Grades are funny. Usually, you see the bell graph where, okay, more people make C's than anything else, right? Only a couple people make A's, a couple people make F's. But in my classes, it's usually a U, right? We got a lot of A's, and then we have, some F's. Only a few C's. I don't know if it's I teach wrong, but I like giving A's, so happy to do that. Okay, so our grading scale going to be slightly different than that, but not much. A third of your grade is based on programming homework. A third of your grade is going to be based on what you type in class. As I lecture, I will be demonstrating code up here. Rather than just show, the worst thing a programming instructor can do, in my opinion, is just show you a page of code and then go to the next slide in the PowerPoint, right? I've had instructors do that and my eyes roll up. I hope nobody's doing that here. But anyways, I'm sure that they have good teaching techniques. I won't say anything bad. But I think that you ought to be typing along if you can. Why? Because you burn in the muscle memory, you engage with it, you learn it better. And so, as I'm giving examples here, I would like for y'all to be typing in the code at the same time with me. If for some reason you can't, that's okay. Just upload a note at the end of the class saying I attended class and I observed the lesson, but usually people want to do it. Okay, so that's the in-class stuff. So every day we meet, we're probably going to have 1 or 2 files that we upload into in-class directories. And those are worth credit. So just by showing up, you get a third of the grade. That's kind of cool. But then you have to do the homework. And we also have 2 exams, right? Midterm and a final. The name final is scary. It's not really a final exam. What it is it's just the exam over Unit 2, right? We have Unit 1 and Unit 2, and it happens to take place at the end of the semester, so calling it a final exam is convenient. But you know how finals have, additional weight in some classes, it's not like that. So 2 exams and quizzes add up to the rest of it. So what we're going to do is we're going to go through the text, we're going to go through the PowerPoints, we're going to be typing code in. You're going to have you're going to have chapter quizzes, like you finish chapter 2, you need to do a quiz for it. If you've taken only my fundamentals class and not Java, then that's not true. We had the Mind Tap this last semester. Anyways, so you're going to have quizzes, but you can take them over and over to get the grade that you want on the quizzes. I consider quizzes as learning opportunities rather than as measuring opportunities, right? The measuring happens during the exams. All right, so our holidays. June 4th actually falls on a Wednesday this week. I'm going to have to update the rest of these. I don't know why. Okay. The last day to withdraw is July 17th. And then we have a last day of class and we have a final exam. And we have a midterm, I believe, on June 27th. But I will post all of these dates. Yeah, let's do that. I'll revise the syllabus and upload it for y'all. Grading policy, if your program doesn't run, you don't get any credit for it. And what do I mean by that? Programs can have mistakes. They don't run correctly, right? They give you the wrong answer, that kind of thing. But if it just flat out doesn't run because of a syntax error. In this language, things have to compile before they'll even try to run. In Python, if your syntax error is halfway down through the program, it may run up to a certain point and then crash with a syntax error. In this language, if there are any syntax errors, it won't even compile. And if it doesn't compile, you get an error message during compilation stage and you can't run the program. If you send me code that doesn't compile, then you're not going to get any credit for it. If, when you submit the file, you fess up right in the little comments field, and you say, I don't know why this is, why this won't compile, then I'm going to be, more generous in my assessment than if you just, give me a .cpp file and it comes up and it won't compile. Yeah. And usually I can tell if, anyways, But if that's the case, you should have been taking pictures of your code, sending it to me, and I would have been helping you with it along the way. But if your program is behaving oddly and you want to let me know about it so that you can prove that you knew that it wasn't behaving right, you want to communicate that, just put that in the comments when you upload it via D2L. So partial credit can be awarded for assignments that do not meet the full criteria, but meet part of the criteria, right? If I wanted to do 4 things and you get it to do 3 things, cool, you'll get partial credit. In either one of these cases, if you don't get any credit because it crashed, it won't compile, or you get partial credit because it runs but it crashes, or it doesn't do everything, you can always revise it and re-upload it for more credit. The only exception would be is if I gave you a 0 for cheating on it. You could upload a different version of it, but I'm not going to give you credit for it. Cheating is a big deal that we're going to spend too much time talking about in just a minute. Alrighty. Programming assignments are due 1 week from the day they are signed. If you get them done on time, you get a 5% grade bonus. That's pretty cool. Late homework will be penalized according to the late assignment policy. Basically, it's 10% a week, and nothing is accepted more than a month late, which is kind of reasonable in a course that only lasts 2 months, right? Yeah, so you must have completed 50% of the programming assignments, though, in order to pass the class. Even if you made hundreds on your exams and quizzes and you attended every day and turned something in and it looked like you might be able to get a C by just doing one program, no, you're going to have to do at least half of the programming assignments. I want you to do them all, right? But if there are 10 of them or 12 of them and you haven't done 5 or 6 or half of them, then it's going to be a problem. But you'll know that, right, as you're coming up. It's not going to be a surprise to you at the end that you didn't get your programs done. So, change this. Take-home homework will be accepted up to 7 days late with a 10% deduction, additional 10% for each week after that. After 4 weeks, no credit given. How about the in-class stuff? You miss a lecture. What are you going to do? You're going to watch the video. You're going to type in the stuff or at least upload a note saying that you watched the video. Do that, upload it, you get credit. But don't wait too long. After 2 weeks, I'm only going to give you half credit for it. Why is that? Because if you miss a lecture and then when you come in on the next one, you're going to be more confused. It's not going to be good for you to be skipping lectures, missing lectures like that. And don't do the thing where you wait until the end of the semester and try to do all your homework. That's not going to work if you're not getting credit, for anything that's more than a month late. If there's serious issues involved, I had to go into UI or something like that, then we can talk about the option of making up homework. But otherwise, try to get it done on time so that you are where everybody else is in the class. Penalties for late assignments might be waived if you talk to me about it. Hey, my wife's pregnant. This is going to be a really hard week. I've got to go out of town. That kind of thing. Talk to me about it, and I'll try to be helpful. If that's the case, if I say, yeah, I'll take that as a late homework with no deduction, within reason, when you upload it, in that comments field, say, you said it was okay to turn this, or as I reminded you, blah, 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 or as I mentioned to you, this is late because of what. Because I might not remember which student told me, their assignment was going to be late. So use that comments field to your advantage. Fill in information about it. So I have to take attendance. I should be taking it at the beginning of every class. For one reason is that if there was a kind of disastrous situation, like an active shooter kind of thing, or whatever, I should be able to prove which students were here and which students were not here, so that if Mary Ellen can't be found, when we all run outside, and I can check attendance and it shows that she was in a classroom, then it's a serious problem. And I didn't take attendance yet, so I should have taken it, before we started the lecture. I will take attendance at the beginning of the class. If you come in, I'm probably not going to know. I'm not going to be updating it every time you walk in. If I passed out a sign-in sheet, of course you can sign in, as you walk in. That's probably actually what I'm going to do. As a general rule, students who attend classes and do not miss many days perform better in the course. But, some people do try to take things as remote classes. And since I record every lecture, you see what's on the screen and you hear my voice, then you can miss days and keep on track with it. But don't Don't get in the habit of doing that, or else the class is not going to go well for you unless you have extraordinary self-discipline. Any student who does not attend class within the first week will be dropped from the course, and AW will be put on your transcript, and you'll still be charged for the class even though you don't get any credit for it. That's not my rule, that's just the campus rule, and it's pretty much the same at every campus. So you will be financially liable for the course, and if anybody was paying you, giving you grant, or funding you, then they're going to come and they're going to get the money back out of you, via whatever means necessary. So obviously you are all here, so that's not going to be, an issue in this class. But just for future knowledge, I have had in the past students, 3 or 4 weeks in, tell me, I didn't know that attendance was mandatory. Well, it's not mandatory, but you weren't watching the videos, you weren't uploading anything, and you never attended class, you were dropped with an AW. And they don't like that, and they argue with it, and it's campus policy, it's not mine. All right, any behavior that is disruptive to fellow students will not be tolerated. The newest one that I had is people watching Twitch videos or whatever during during class. I don't know why they thought that was a cool idea, but I didn't yell at them about it, so they didn't stop. But it was distracting to the people behind them, and so if I see stuff like that, I'm going to mention it, which will embarrass me and embarrass you. In general, don't put anything on your screen that's going to distract the people behind you, right? You can distract yourself, and you accept your own consequences for distracting yourself, but if you're distracting the people around you, it's totally not fair. If you have your head buried in Facebook or Twitter or stuff like that, you're not going to be learning very well. So I recommend that you don't do much with your portable things, except if somebody needs to contact you. I understand that people have children or significant others or whatever, and you may need to be paying attention if somebody sends you a text, but just have your stuff on silent. If you need to make a call or engage in a heavy text conversation with somebody, you might step out of the room. You will step out of the room for phone calls, right? Okay, no vapes. When vapes first came out, people thought that they could argue with the professor and say that it wasn't smoking. I don't know why they thought that to be the case. All right, instructor expectations. I will always give you a week's notice of due assignments. I will give you 2 weeks notice of exams. I've actually given you considerably more than that since they're in the semester, but if they change, you'll know in advance. I'm never going to spring an exam on you, and I'm never going to have y'all come in on Monday and tell you that you have to have something turned in by Wednesday. I don't think that's too cool. So you'll always have a week to do the homework. All due dates will be posted clearly in D2L. If you go to D2L and check the check the assignments page, right? All the assignments will be listed there. All the due dates will be listed there. So really no excuse for not knowing when something is due. The only exception to that is, what if I forget to put a due date on it? If you notice me forgetting to put a due date on it, please text me so I can put one on it. And what I'll do in general is make it due a week from that point, right? It's not fair for me to have left a due date off and then, the night before class say, oh, it was due tonight. Yeah, that's not cool. But in general, just text me if I don't notice that I forgot to put a due date on it. That doesn't happen very often, but it can. I will grade things within a week of submission. If there are errors in it, you will not receive full credit, but you can correct and revise. It's not your final answer. All important class announcements will be posted in D2L. I think you all get notices. What kind of notice do you get in your email when I post something on D2L? What do y'all see? Anything?
Nothing in email, just the bell icon at the top tells us something was posted.
But it doesn't actually tell you what it was?
You can click on it and see.
Oh, okay, all right, well. Sometimes I'll email y'all as well, separately, if I think that it's really important. If I think it's really, really important, like, the final is canceled because, I'm in the hospital, something stupid like that. It won't be canceled, but you'd have to take it, at the library or something like that. I will text everybody if it's within my power to do so. All right. So if you send me an email during the work week, I should always respond within 24 hours. If it goes longer than that, then something's wrong. The email got misfiled, or I attempted to send it and it didn't send, something like that. Text messages get responded to much more quickly. If you send me email or you leave me voicemail and I don't respond quickly, feel free to text me. It's not that you're hectoring me, it's that you're getting the service that you need, right? I am an employee of you. Office hours are offered for face-to-face consultations. All right, academic integrity, also known as the cheating rules. How can you cheat in a programming class? You could copy from somebody else's work. You could ask them to write their program for you. The worst thing that you can do in terms of, well, what if I can't get something done, and so I asked Mary Ellen if I can look at her code, and she says, oh, let me just email it to you. And, okay, great, I have this. I just upload her solution. Cool, right? No, it's not cool, because I will probably spot it. If that happens, then not only are you going to fail it and get a 0%, she's going to fail it too. And she's going to be really unhappy about this. And this is not a theoretical example. I've had this happen to people before, when one person would, let the other person look at their code, and instead they would upload their work, right? So that collaboration, if you write your code, you share it with somebody else, then both of y'all are considered culpable, guilty. And what happens in that case is that you get a 0 for that assignment, and it gets reported to the division dean, and it also gets reported to the director of student conduct. And worse things can happen: being dropped from a class, being expelled from school. Why does it get escalated, all the way down to the dean and the director of student conduct? Is that people figured out that, lots of professors want to be nice guys and go, okay, it was a first offense, and you're saying, well, I had a reason. I was sick that week. I couldn't even think. I didn't mean to upload that, whatever. And then it turns out that if you check with other instructors that person has had, that, it's also happened in their classes. And so it's not a one-time thing. They've been trying it in every class, and they're not having been caught in every class. So it is now school policy that's how, academic integrity violations are handled. So don't turn in somebody else's work. You can't collaborate on your homework. The situation where, that gets kind of iffy is if you're living with somebody and you're both taking the same class and you're both using the same computer in order to do your homework. It is so tempting for y'all to sit there and work on it together, right? But you need to do your own work. I have to look at everything that you submit, and if I see two programs that are too similar, then it's going to raise some red flags. We're going to talk about it. That's one thing. In class is a different matter. Now y'all aren't buddying up with two people per per row, but you could if you wanted to. And why would that matter? Because as we're typing in code up here, y'all could be looking over each other's shoulders. Because what I do is I do a little walkabout, making sure that everybody's at the same place, and all the syntax errors are corrected and stuff. And if you're stuck and someone was sitting next to you and they were done, they could look at your screen and go, you forgot your semicolon, or your brace placement is off, or something like that. But that's not going to really matter too much for y'all, because we don't have a crowded class. Then what happens is that people get used to collaborating with their partner, right? And so they extend that relationship to working on programs together out of class. Now, the one place where it gets into a gray area is just like when you're writing a paper for a history class or whatever. What do? You go and research it, right? Google is your best friend, or Bing, if you hate Google, for learning programming, right? I ask you how to, I ask you to print an array with a loop. So you do print an array with a loop, C++, excuse me, and you go and you see all sorts of places offering help. Okay, sometimes the answers are very short, sometimes they're insane, right? If they're insane and that's what you turn in, then I'm going to know you just copied it, that you didn't even comprehend what you were copying. Just like if you copy and paste something from an online source and paste it into your English paper or your history paper, they're going to catch you, because almost every instructor runs your papers through something called Turnitin, which checks for plagiarism against a database of other people, whatever. So same thing. But this one just shows you how to do it. Take what you see and adopt it in your own code. Don't just copy paste it. Take what you see, put it in your own code, in your own style. If it's written in something like this that looks way beyond what we have learned, then I'm going to know that it was copied off the internet, and I'm going to be able to find the source of it, and I'm going to treat it as academic integrity violation. But that's the gray area, right? Is that you can go too far in using the internet as a resource. You could also just flat out cheat. There are people who compile, databases of professors' homework assignments and stuff like that, and I don't know if mine are out there. I do change them from semester to semester, but not everyone. It's possible you can find one of mine, but don't do that. Don't turn in anybody else's work. You're paying good money, or somebody's paying good money for you to be here. Take advantage of it. Learn as much as you can. Do your own work. I will help you a lot, and like I said, most people make A's in my classes because, if I'm sitting there helping you on it and you're applying yourself, then you're going to do well in the course. You're going to want to read the syllabus besides what I just do here to make absolutely sure that you understand it all. All right. If you have, used to be called the Office of Disabilities, they've changed the name of the department to something else because that's what people got to do, But if you need assistance in some fashion outside of what is normally offered in a class, like you're dyslexic, those things are difficult to read, you can only type with one hand, there are things that the instructor can offer you or that you can ask for. Solutions might be, I need to videotape the class, right? I need to have, a camera aimed at you in order to do it or whatever. That's cool. I need to be in the front row. Okay, that's cool. If the front row was full, then I would ask, that person to swap out so that you could do that. I need more time on the exams, that kind of thing. The most help I've ever had to offer was somebody who needed me to sit there and read the questions of the exams to them, and so we did it on our own time, and I did that. I would read the questions of the exam to them, and they were a good programmer, but they had a real hard time processing, visual data, and they went to the Office of Disabilities, they filled out a worksheet, got sent to me, and I helped them with it. So you have options if you need help. Alrighty, I hope that by this point, if y'all aren't new students, you know how to access your email. Your account is first name dash last name for the most part. However, your D2L password is different. It's your Rose ID, your first letter, first initial, last initial, followed by the 6 digits of your number. I don't know why they can't use the same, ID for everything, but whatever. So to log in a computer, you use your student ID. To access your email, you use your first name, last name. If you get stuck, you can get help with Raider email there. If you need D2L help, you can go to another link and leave a message and give them your phone number, and they'll call you back amazingly quickly. Our D2L team is incredibly responsive. It's the same tool that the professors use by and large, right? If we're getting stuck, we just go to that webpage, we fill it out, just like y'all. And they're great guys. Alrighty. Any questions over the syllabus or class policies that we've talked about so far? Hope that made sense. Yes, sir.
The textbook, will any C++ textbook work? Or
You're going to want the one that's specified. I don't mind if you get a slightly older version in order to save money. You're just going to want to make sure you get it pretty quickly. All right, that was a good question. Anybody else? Alrighty, gang, since this is a 2.5-hour class, I need to remember for us to take a break like an hour or so in, but we haven't hit that point yet. So, your first homework assignment is going to be to install Visual Studio or another C++ development environment and to tell me that you did so. So, it looks like the pages for the information about how to install that are not there yet. Let's do that right now. You don't have to install it on these school computers, right? But let's get that information. 5156. Alright, so to download Visual Studio, we use something called DreamSpark. Or it used to be called DreamSpark. Now it's called Imagine. Alright, so anyways, you're going to go to dreamspark.rose.edu. You're going to sign in. You probably don't have an account there yet unless you downloaded something last semester. So you're going to click Register. It doesn't say not register, it says not register. Something like that. Enter your username, which is your Rose email address. You'll be prompted to finish the registration process. Let's pretend that we're going to install this stuff right here. So I would go to dreamspark.rose.edu. I would click Register. I'm going to provide my username, JG Thompson. You're going to do your rater.rose.edu address, right? You're going to click Continue, and it will send a message to Arlene Hayes, who manages our DreamSpark, and she'll turn around and validate your account, almost instantly, and you'll get an email notice of that. And then once that happens, you can log in and download stuff. Alrighty. Looks like I am not registered, so I'm actually going to be doing this. Alrighty then. Apparently I've forgotten my password. Isn't that cute? Alright, so anyways, that's what you're going to do. When I said almost instantly, it's not like she's there in her office, just doing these. So you're probably not going to get an instantaneous response unless they've automated it. But by tomorrow or Wednesday or whatever, I'm sure that you'll be able to log in. What version do you want to get? Well, we're using an old version in this class. If you come to the Start box, click Windows and type in Visual Studio, you're going to see that, we're kicking it old school with Visual Studio 2013. Are you going to want that? You could do that. Just get the newer version. Get 2017 or, some reasonably new version of it and install it. When I have my account revalidated, I'll post a screenshot telling you specifically which version I want you to install. Does this mean you have to install Visual Studio? No, like I said, you can go and you can find other C++ development software. You could find C++ for Windows and see if you can find something that'll help you, download free compilers, right? This message is old from 2008, but you can find other compilers for C++. One thing you could do is, if you want to use something that's a little more cross-platform compatible, is you could download, and I'll give instructions for this because I'm having my other class do this. You could download Cygwin and then you could install Eclipse for C++. I'll give you all the exact specifications. And that's if you don't want to use any Microsoft specific stuff. That's totally cool. You know, but Visual Studio, it's free for you. There's lots of other stuff available for you on DreamSpark as well as C++. About the only thing they don't offer is Office and, you know, Word and stuff like that. And we have other links where you can try to download those for free for students as well. Maybe you've already got them because you've had that notice from other classes. I'll post all those notes. Not sure why they weren't in that last one that I just posted. Okay, notes to self. Free software links. Updated syllabus. That's really lame, and I apologize, guys. I did not realize that my Google Drive was not refreshing. Okay. All right. So what are we going to do? Are we going to start lecturing, or are we going to write a program right away? I think we're going to write a program right away. So as long as you're logged on, you ought to be able to do this. Go to the box, start Visual Studio. Takes a minute to launch. It didn't take much time at all on mine because I've been launching it all day. But take a minute to install, and it'll come up here. And what you're going to want to do is choose File, New, Project. If you notice, there is a place where you can specify the location. Right? It's got some odd default. And if you're really in bad shape, it'll be defaulting to something in some admin account that you don't even have write access to. So if you click OK and it doesn't create it, that's probably why, and you're going to want to pick a different location for it. You could even, you know, do this stuff on a flash drive or whatever. But, you know, what I did is I just went to the desktop. I did a new folder there, and, you know, save all my stuff there so that I know where to find it. And you're going to choose Empty Project. If you choose another one of these options, it's going to be creating something that's very Microsoft specific. And what do I mean by that? It's going to be using words and function calls that won't even compile on anything else other than Visual Studio. Do we want to learn how to program like that? Not in this class. You just want to learn C++. So we're going to make an empty project, and then we're going to add our own source files to it. Now I'm going to call this one June 4, except I've already called it that in another class that I just taught, so I'm going to call it, you know, anyways, June 4 or first program or whatever you want to call it. That's the project name. In Python, if you used idle, you did not have this concept of creating a project and then creating source code, right? But in Java, you did. So if you've taken a Java course, you're familiar with the idea that the project is not the source code. You create one and then you create the other. So we're creating the project, which is a directory. But it's an empty project, just like we specified. Keep forgetting something. So we give a project name, it comes up with an empty project. If you do not see this box over here that says Solution Explorer, you need to enable Solution Explorer under View. So, View Solution Explorer if need be. And you'll know because if you don't have the Solution Explorer available to you, there's nowhere to create your files. Right? Nothing over here looks like you could right-click on it and create a file. So, View, Solution Explorer. And we can see where it says Source Files. We're going to right-click on that and do Add New Item. So, Solution Explorer, Source Files, Add New Item, and you're going to choose a C++ file. And here I don't really care what the file name is. It could be source.cpp. I would just call it the same thing as the project name, June 4. If you upload everything and they're all called source.cpp, that's fine until you have to start writing programs that are complex enough to have more than one C file in them. All right, and then it comes up with an empty slate. If you've used NetBeans, you were used to the idea that when you created your program, it put all sorts of boilerplate in, right? In Python didn't do that, so this is more like what happens when you create a new file in Python. You have absolutely nothing. So every time we start one of these programs, we're going to be typing in what I call boilerplate. What I strongly recommend is that you just copy the boilerplate into a text document, paste it, and save it to your desktop so that you can copy and paste it rather than have to type this stuff in every single time. But we don't have that boilerplate document, so we're going to type this, #include, and it's okay, you don't know what this stuff is yet, but it's like, before you learn to play tennis, you watch a match of tennis. So, #include IOStream. This is like the import statement in Python and in Java. Now this is completely unlike anything we've seen in Java or Python. Using namespace std. And by the way, I'm going to say that this is poor manners, and as a professional programmer, if you're going to be putting code on the internet or something like that, you're not going to want to do this. And I will explain what it does, how it makes things simpler, which it does, and then how to get around not doing it anymore after a certain point, once we no longer need training wheels. But it makes things easier. Okay, now we're going to define our main function. Every program you write has to have a main function. Even if you're using a framework where you just generated a program, using these dialogues and it came up, there is a main function, even if you didn't write it. So int main, parentheses, end parentheses. And then beginning quote and close quote. Now, you Python folks are used to formatting your code with tabs. That's great. You're still going to use tabs, but that's not how you mark off blocks of code. In this language, every block of code starts with an open brace and ends with a closing brace. And indentions don't matter as much as a result of that. You don't have to indent at all. It makes your code look ugly. It makes it to where I and nobody else can read it. I strongly recommend you do indent your code, but it's not necessary, unlike the way it was in Python. And you Java guys are already used to those ideas. Okay, so what are we going to do? We're just going to print something. I love C++. So I typed in cout and an arrow, and that was less than, the shift comma. And then, I'll answer you in just a second, quote, I love C++, end quote, or exclamation point, end quote, semicolon. And then we're going to put a pause command in there. What's the pause command do? I'll show you just in a minute. So you're going to type in, as the last line of code, system, parentheses, quote, pause, end quote, and these have to be double quotes, unlike Python where you can mix and match them. And end parentheses, end semicolon. Notice that we're using semicolons a lot. Yes, sir?
I'm still trying to get everything opened up.
I'll say, okay, right click, add, new item, give it a good file name, or you can just accept source.cpp as a default. And then you're going to type in what I've typed. Oh, you got into it already. It must be out of here. Cool. All right. Then run it and see what it does. If you have mistyped something, you might get a syntax error. Won't compile. How you run it? Oh, I didn't tell you how to run it. Good idea. Well, why don't you just run it? All right, so let's rebuild the solution. Choose build, rebuild. And that runs the compiler. And I can't see the output window. It's down here, but if I pull up my little text thing, I'll see output. I don't see anything there. It says rebuild all succeeded. What if there was an error? Would I have seen something there? I'm going to make an error. I'm going to take the C out of cout. You don't have to do this because it's an error, right? But then when I do rebuild solution, the output window does show some stuff, right? It tells me the line number of the error, and it tries to give you some helpful information, although it may be written in, a technical phrases that we don't understand yet. undeclared identifier. Okay, but it's telling me what line number it is. It's giving me a code that I could go and Google up to understand what that means. So in line number 6, out is an undeclared identifier. You could go to line number 6. Well, I don't even have line numbers. There's a way that you can enable line numbers to go down the side. I forget how to do that. I usually don't need to, because if I go to the error list, I can just double click on it. It'll take me to the error. Now, if you make a mistake, like if you've typed in a page full of code and then you build it and you see 100 errors here, does it mean that there are 100 errors in your code? No, it probably means that there's one mistake that you fix and it's going to make 90% of the other ones go away, right? Because as soon as it goes off the rail, everything after that's probably going to be considered an error as well. I'll give you an example of that. What if I left out this opening brace, or I had a closing brace in the wrong place? Then when I built it, it's going to show a lot of errors most likely. Look at that. Oh man, I'm such a bad programmer. I have 11 errors. No, it's just that one thing needed to be fixed. So what you want to do is, after you get an error, you look at the error list, you double click on the top one, you read the little message about it, you see if you can figure out what's wrong, you finally fix it, and then you rebuild it. You don't have to then click on the second one and the third one and the fourth one and try to fix them all. Just fix one at a time. Usually you fix one thing and it fixes half the errors. In this case, it's going to fix all of them. Alrighty. Now we want to run it. You could just go for the green arrow, but there's other ways to run it too. Under debug, there is start debugging, or there's start without debugging. Doesn't matter which one we pick at this point. So I'm just going to hit the green arrow. And it says, I love C++. Press any key to continue. Now that's kind of lame, right? Because this press any key to continue ought to be on its own line. That's the result of the pause command down here. If you're doing this in something other than Visual Studio, you won't even need the pause command. And if you're on Mac or Linux, then that would probably be an error. You would just delete it completely. But what is that there for? Let me get rid of this. Get rid of this in quotes, because all I'm going to do is comment it out so it's no longer actively part of the code. And then when I run it, wow, what'd it do? Well, that's invigorating, right? What it's doing is it's running it, it's printing its message, and it's closing the window instantaneously. Now there's other ways of fixing that behavior, and what I mean by fixing is to get it to pause so that we can see the output. But this is one way. It's kind of half cheesy, but it's like the easiest way. And if you're doing it under something other than Visual Studio, you probably won't put that in there. Okay, so what is our problem here? Our problem here is that we don't have an end of line marker after our message. So I'm going to add an end of line marker. That's different than it was in Python, right, where it went to the next line automatically. Two ways you can do an end of line marker. One is they give you something called ENDL. You can do arrow after your quote, but before your semicolon. You can do arrow, arrow, ENDL. That's one way to fix it. And then you hit local window debugger, and it runs, and the pause message happens on the next line. Now you really do need to close this before you make any further changes, or at least before you run it. What do I mean by that? Well, it says press any key to continue. Do you remember how in Python you could keep running your program over and over and it wasn't a problem? Well, this actually creates and runs an executable, and then if I make a change and I try to run it again without having closed that window, well, see, it's not going to even let me do it. Rebuild solution, do you want to stop debugging? And maybe it'll work, but maybe it's not. Sometimes it'll look like it's running the same code over and over. Sometimes it gets so bad you actually have to quit Visual Studio and relaunch it to get things to work. If your code looks like no matter what you change, it's not having any effect, like what if I change that to I love D++? That should be real obvious, right? When I run it, it should say D++. But if I made that change and it still said C++, I know that it's just gone out of whack, and you ought to close it and you ought to open it back up. And I've had a couple students need to do that like one each semester. So that's just something to remember. But what was I babbling about? I was babbling about the fact that we need to close our program here. Sometimes it will complain that file is open and it can't be overwritten, right? So, and if that's the case, it can't compile it and create a new exe because the operating system has the current one locked. So you actually do want to close these little programs, and sometimes you wind up with like 4 or 5 of them going on down here, but you just find the one that looks like the little, icon like that, and you close it, and then you're good to go to run it again. By the way, do you have to do this rebuild step? No, you probably noticed that I made a change and I just went for local Windows debugger, and it asked me the project is out of date, would you like to build it? Well, heck yeah, and as a matter of fact, I may as well do not show this dialog again, so that every time I run it, it'll compile it automatically. Now I like that behavior. But if your program starts behaving bizarrely, like that case I told you about where you make a change and you're not even seeing the results, that's a good time to go ahead and do build rebuild solution. What that does is it recompiles everything, and if you had multiple C files in the same project, it would compile them all. Okay, so one thing you'll see is this error. No, that didn't happen. Sorry, I'm spacing out. That's not an error, is it? This is an error. I introduce an error. I don't realize it. I run the debugger and it says, there were build errors. Would you like to continue and run the last successful build? You never want to run the last one. You want to fix the problem. You're always going to choose no. As a matter of fact, I would click do not show this dialog again and then choose no. But maybe I like seeing that error message. It just flat out hammers in the fact that it didn't run. It won't compile. So then I'd have to go and fix it. I could go to the error list, double click on the error, take me to the... While we're at it, let's see if we can figure out how to enable line numbers, just because they're kind of useful. Tools, customize. Nope, that's not it. Always forget semester from semester. Tools, options. Do a search for numbers. General, line numbers. I'll walk through those steps again. Tools, options. Go up to search options, type in numbers. Text editor, all languages, general. Line numbers. All right. I just like seeing these down here because that way I can look, and when it says that it was in line number 6, I know. Or if I look at the output, I don't even have to look at the error list. I just see what line number it was in, right? Line number 6. I don't know why it's not shown in default. Now, when you're typing code in, it's not going to necessarily have the same line numbers as mine code does unless you type it in exactly as I do. And the likelihood of that, diminishes as I start adding comments that you don't put, or, I put in a lot of white space and you leave it out or whatever. So the line numbers are not going to directly correspond. They're just for figuring out what the error messages are. Okay, so at this point, hopefully, we have something that prints and displays a message and then waits for us to exit the window. And so I think this would be a good point to take, our bathroom break and run and go get stuff from the Coke machine and stuff like that. So why don't we get back together at about, 8:16, an odd number. So if you need to take a break, that's cool. It's not running for you. Let's figure out what's going on.
Oh, no, it's fine.
That weird. I guess it's a new version.
That's right.
Yeah. Why is there such a broad price range? $19 to or $31. Okay, that's if you rent it. All right. The only thing you have to be careful about is if you rent it, make sure you get it back to them, right? Because otherwise you get charged more than if you just bought it to begin with.
Sure, there was a Kindle version of this? Or
Yes, there is. Yeah.
Is it the 8th edition or is it? Yeah, I ordered the 8th edition. Is
No,
there
no.
any, is there any harm in that?
Absolutely. Absolutely not. Wow. There's no Kindle edition at all.
I mean, that's the editions.
Well, what do you know?
Probably before.
Yeah. That's what it costs.
See, yeah.
Sure. Now, to me, it annoys me when Kindle books or whatever are so dang expensive because, you know, they're not having to print it and deliver it, you know, and stuff like that. And yet they're usually more nowadays than the actual physical books are. But I know the authors want their money. But still.
The 8th or 9th doesn't matter.
Nah, not really. And I didn't pause it, so everybody watching the video at home just had to fast forward 5 minutes past our bathroom break. Oh well. Alrighty. Now the bad thing is when I pause it and don't resume it. I'd rather make the other mistake that I just made. Alrighty guys, so we're going to actually hit the PowerPoint now. Now let's do one more thing. Since presumably y'all have done other programming, you want to know how to do input as well as output. So what we're going to do is let's replace this one that says I love C++. Let's change that a little bit. How about making it say, please enter your name, first name. I wonder if enabling the line numbers means that it's taking up more space over here, and I might want to get rid of them since I try to get as much stuff on the screen as possible. I'm going to remove them now. Yeah, that is the case. Okay. All right. Above that, let's declare two variables, one for the first name, one for the last name. And they need to be strings. Remember in Java, if you took it, you had to use uppercase S. If you haven't taken Java, yeah, who cares? Instead, we're going to use lowercase s. And if I could actually type, it'd be great. String space F name, comma, L name. Now I've made a mistake here. My mistake is that I have not done an include string. So come up and above the using namespace, either above or below the IO stream, add # include ankle brace string. Alrighty. So we've asked them for their first name. Let's let them type it in. CIN arrow F name end semicolon. Now that's a difference from Python, right? We didn't end everything in a semicolon. You may get frustrated when there are places where putting a semicolon causes an error and places where if you leave it off it causes an error, and we'll drill down into that. I'm absolutely sure that some of the errors I'm going to help y'all correct will involve semicolon placement, but you'll get the hang of it really fast. There is one simple rule. Okay, so now let's do another one. We could just copy and paste those 2 lines to speed up our typing, but here's what I'm going to do. Cout arrow Alright, if you happen to step out later than everybody else, just make sure you get this line in as well, because we added this up here. So make sure you get that. Make sure you get everything below here. Alright, okay. So cout arrow, please enter your last name. Now I'm not going to use ENDL this time. Instead I'm going to use \n. The backslash is the one above the enter key, not next to the shift key. End quote, semicolon. And we want to read the user's response and store it in the L name variable. Now that's an L and not a 1. I know they look similar. Alrighty, now let's print a message. Cout arrow hello, comma, space, end quote, arrow, and I'm calling them arrows, but you know they're less than. And then let's do F name, arrow L name, arrow quote, exclamation point, \n. Now there's a slight bug in what I've done here. So it's not necessarily a bug, but I'll show you. Run it and our output is not going to be optimal. Alright, please enter your first name. Oh, I need to get rid of the Solution Explorer because it blocks off a lot of source code. Sorry, guys. Okay. Please enter your first name, Bob. Enter your last name, Dylan. Hello, Bob Dylan. What would make it prettier? A space between the first and the last name. Well, let's fix that. I'm going to come here and in front of that L name, right? I'm going to make it kind of easier for me to read by just hitting enter before the arrow there, like that. But then I'm going to come back up here, and after L name I'm going to do 2 more arrows followed by an open quote and a space and a closed quote. Now you don't have to break it into 2 lines like that, but my screen real estate is different than yours since I put my font to such a large size and I have the screen set to a low resolution. If I took that character turnout, it would look like this, right? It would just be all one statement. If you don't like filling your stuff up with spaces the way I do, you can remove almost every one of these spaces. That's how you like it, that's fine. I space things out a lot to make it easier for people in the back row to see what it is. To me, that's harder to read. But if that's how you want to do it, that's cool. I'm going to put the spaces back in. All right, so now when it runs, it should say hello, first name, space, last name. Bob Dylan. There we go. And it says hello, comma, Bob Dylan. So we've demonstrated using input and output. We've demonstrated variables. We have 2 string variables here. Why did I do this # include string here? What happens if I remove that? Does the code still work? And the answer is no. What's going on here is that C++ is kind of like Noah's Ark that would be built over decades. It was based on C, and then things were introduced in C++, and then things were modified, and then new classes were introduced, and new classes were introduced. There is something called a string in the original C++ specification, but it's not a class. It's just a remapping of a different data type. And it doesn't support these fancy features. But there's a string class, which has the absolute same name, which is insane. I would prefer that they would have done the Java, thing of making it an uppercase S to distinguish between the two. But they didn't, and so in order to get it to work, we have to have our include the string library there. That kind of gives us a clue as to the fact that you can have multiple things with the same name, and that those names can conflict with each other. There's a string class, and then there's a string data type, and we're overriding one with the other. There are things that we can do to specify which one we are trying to use. We can prefix them with some letters that say, no, I really want to be using the string class rather than the other one. But we're not going to talk about that now. So we have 2 variables. These are called streams, like a stream of water, not strings of thread. This is an output stream. It's displayed at a console, that's why it's called cout. This is an input stream. It's reading from the console, and that's why it's called cin. Now I call it cin, I don't usually say cin, right? But you know that now that you've seen it once. Hopefully it'll stick in your brain. And the arrows are called stream insertion operators, and this is like the only language in which I've ever seen that uses these things, and they're very quirky and idiosyncratic. The guy who invented C++, brilliant guy, and they're very useful, but they're very, very idiosyncratic. And if you've used other programming languages, you know that this looks a lot different than it did in Python, where you just do something like x is equal to input, or in Java, where you use the scanner to read it in. But all right, so we've got our program running. We've seen a block of code. We've seen how you define a block of code with the square braces. We've seen defining a function. You define a function by giving it a data type, which you did not do in Python. You did not. All you did is use a def keyword, and it didn't matter what data type was returned. We've seen that you don't end things in parentheses. You don't end things in colons, like if statements and define statements like you did in Python. Instead, you use curly braces to mark off your blocks of code. You see how you end all these statements in semicolons. There's one except the general rule of thumb. There's 2 exceptions. You could say every statement ends in a semicolon except if it is followed by a brace. If I put a semicolon here, it's followed by a brace. That breaks the code right there. So you never put a semicolon on a line that is followed by a brace. Now, is that the only point where that could come and bite you? No, let me go and type in something else. You could type this in too if you wanted to. If parentheses, fname equals quote Donald, end quote, open brace, cout, good morning, comma, Mr. President, exclamation point, backslash, in semicolon. That's an if statement. But what if we were in the habit of ending every single thing with a semicolon? And I put a semicolon there. Now that doesn't stop the code from compiling. It's not a flat out syntax error, but it is a logical error. And with that semicolon breaks the code in such a way that it will print good morning, Mr. President, no matter whether the first name is equal to Donald or not. So that one is more subtle. At least this one flat out doesn't compile. You get an error message and so you can go and fix it. This one does compile, it's just a logical error, and those are harder to track. Just as a general rule of thumb, if it's an if statement, a for statement, or a while statement, no semicolon. If it's a function declaration, no semicolon. If it's before a opening brace, no semicolon. The last exception is pound sign includes, no semicolon. Everything else should have a semicolon. And that'll become second nature very quickly to you. Alrighty.
Having a bunch of errors.
Well, then I'm glad you stopped me, because if I haven't said so before, please don't let me get ahead. And I'll probably say this every single time I view a PowerPoint, but I never use the preview function in D2L. I always actually download the file and view it, because this little preview is for the birds. It's hard to work with if it's a lot of pages long. Alrighty, Introduction to Computers and Programming, C++. Why program? Alright, these chapter 1s in every programming book are usually somewhat annoying. What is a computer? Programmable machine designed to follow instructions. What is a program? It's the instructions that the computer follows. Kind of a tautology there. The programmer is the person who writes the instructions. So without programmers, without programs, without... Alright, anyways, yeah. At a certain point, I'm going to get up on the board and I'm going to give y'all a lecture about what a computer is effectively, just to try to burn it into your brain in a very, very simple fashion that may be a little bit different than the way you're thinking about it. And if you took fundamentals with me, you've already heard the lecture, but just think of how lucky you are to hear it again. All right, I'm going to skip a lot of these things because I trust that y'all can read the book once you get it in. What is the central processing? What is the main memory? What is secondary memory? Well, I guess I'll mention this. You've heard of RAM. I bought a computer and it had 8 gigabytes of RAM. That's your main memory. And then, oh, I bought a 2 terabyte hard drive. That's your secondary memory. Phones and stuff like that have a similar breakdown. You buy a phone, your iPhone has a certain amount of RAM. It's only a couple of gigabytes. And then it has secondary memory storage, 32, 64, 128, or whatever gigabytes, something like that. So that's flash RAM. It's not a hard drive. You don't have little spinning devices. The first iPods, did actually have hard drives in them, but now nothing has a little hard drive in it. Anyways, and so we know what an input device is. It's like a keyboard, and we know what an output device is, a printer or a screen or something. See, this is good stuff, and I will come back to it. This stuff is important, actually. I'm not going to skip past it. Main memory, volatile, meaning that you turn it off. You turn it back on. I may wind up doing the intro, what is a computer lecture right now. What is main memory? It's just a long series of places where numbers can be stored, and the numbers are stored as zeros and ones. That's all that a computer can understand, is a 0 and a 1. Why is that? Well, because fundamentally it has to be stored on some kind of medium and the medium just composed like, punch cards. If a hole was punched out, that was a 1. If there was no hole there, that was a 0. Or you're reading from a CD-ROM. If there was a hole burned into the CD-ROM in a certain orientation, then that was a 0. And if it was burned in with a different orientation, that's a 1. So you had CD burners that would burn into the aluminum substrate of the CD. Hard drives, the same way. You have some electrons, and if they're lined up one way, that's a 0. And if they're lined up another way, that's a 1. When you're reading from the hard drive, these signals are being sent down a wire. And if there's a little bit of current there, then that's a 1. And then the absence of that current is treated as a 0. So you have, those are called bits, on and off. And on is a 1, and off is a 0. Zeros are also sometimes called falses in a different context, and 1s are sometimes called trues. Now, really, they are grouped together. You don't usually talk about just one bit of information. Instead, they are retrieved in memory in groups of 8. Why 8? Well, that was just an arbitrary distinction. While computers were being invented and stuff like that, some people used, 10-bit word sizes, or 6-bit word sizes, or whatever. But 8 became a standard, and it's pretty much what people talk about. So, and byte is 8 consecutive bits. So that means that you could have the numbers. Byte is 8 bits. A bit is either a 1 or a 0. See, a byte can hold anything from 0000, 0000, up to 1111, 1111. And so if you turn the binary into decimal, then that is the value of decimal base 10 of 0. That is the value of decimal 255, meaning that a byte can hold any of 256 different values. So back when you bought your Nintendo and it had 64 kilobytes of RAM in it, that's probably optimistic. That's more like the Commodore 64 or anything. But a K stands for 1,000, roughly. So if you had 64 kilobytes, that's roughly equal to 64,000 bytes. Now if you think about it, like if you download an MP3, it might be 5 megabytes. Let's figure out mega meaning million. So if we have 5 million, 1, 2, 3, 4, 5, 6, and we divide it by 64,000, 2, 3, it would take 78 Commodore 64s in order to hold one MP3. That's a stupid thing to think about, but memory sizes and processors have increased so astonishingly, profoundly much, over the past 30, 40 years, that we get to do stuff that was just flat out impossible. There was no way that you could load, a music file that was that size. That's why video game music, with your old Nintendos and your Genesises and stuff like that were, just really, cheesy tunes being generated, by the chip rather than being, the full symphonic orchestra, whatever stuff, and I like that stuff actually, the primitive music and stuff like that. But think about how, don't think about it. All right, so what is a computer? And you guys watching a video at home aren't going to get to see this because I'm going to be drawing on the board. But you get to listen. And if you've heard this lecture before, I apologize, but only a couple of y'all have. So, you got a little thing, a little dude, in a box. His name is Chip. All right, clever. Okay, and he's got access to a nearly infinitely long piece of paper, like a to-do list, where each line has got a number. But I'm going to start counting at 0 because We're programmers and we're weird. We start counting at 0 rather than 1. Now our infinitely long piece of paper, every line is actually just 1 byte. It can hold 1 number. But ignoring that fact. Okay. And so this is his memory. This is his volatile memory. This is his RAM. It's just a piece of paper that he can read from and he can write to. He's got a pencil and he can write numbers in it and he can scroll this up and down to get to the right information. And then somewhere else he's going to have a series of instructions telling him what to do. So we're going to make up a little programming language that tells Chip exactly what to do. Now, along with this RAM, he has little places in here that he can write information as well. He's got, you know, a little box in the wall, a little whiteboard. And he's called this one R1 and he's called this one R2. It's registers. Registers are places inside your chip that also hold data, but they're profoundly hundreds of times faster than your RAM. So they're very good places to be storing data. And the chip uses them in order to do its processing. Numbers are loaded into them and then manipulated inside the registers. Okay, so our instructions might be read address 3 into R1. That might be one instruction. We're going to note that it's just RD. It's a read operation. Address 3. Okay. And then we would have another one. Read address 5 into R2. That's another read opcode. Op stands for operation. A chip is designed so that it follows these specific commands. And these also have numbers. Read might be 0, 1, and then there might be another one, another command, write, which is opcode 2, 2, and so on. And a modern processor has, hundreds upon hundreds of opcodes to perform specialized operations and to do things, very quickly or whatever. Ours is only going to have like 3 or 4 opcodes by the time we're done. Okay, and then there's going to be an add opcode. And the add, what we're going to do is we're going to add R1 and R2, storing in R3. And then we're going to have one more opcode, which is going to be a write opcode, where we write what is in R3 into memory address 3. Okay, so this was supposed to be a 5. That looks like an S, so I'm going to make it a 4 instead. Okay, so here's our program. Why don't we give these numbers as well? This is going to be like programming step 0, programming step 1, programming step 2, programming step 3, and then the last one is going to be jump to programming step 0. So P3, P2, P1, P, and this is going to be programming step 4, which is just a jump. Okay, so we have Chip. He's got a series of instructions to follow, and he's got this paper, this memory that he can write to, read from. And it's not as far-fetched as you might think. Think back to the days of the paper tape computers. So anyways, first thing, read A3 into R1. Well, we don't have any data here yet, so I'm going to just write some numbers. I'm going to say that 0 has a 7 in it, and 1 has an 8 in it, and 2 has a 9 in it, and 3 has a 10 in it, and 4 has an 11, and 5 has a 12 in it. Right? That'll do. Okay. So, read A3 into R1. So what's A3? It's a 10. So he writes 10 down. And then So every clock tick or every instruction pulse, he does something. And then he waits for the next clock tick to tell him to do something else. So he handles that process. And then the next clock tick comes along and says, okay, now you got to do the next thing. So he's got a pointer. He's got a little box in here that tells him which step he's on. Well, I was on step 0. My clock tick tells me I'm going to go to the next step. Okay, so he goes to the next step, which is add this value 4 into R2. Okay. And then the next step, add R1 and R2, storing into R3. Well, we didn't have an R3, so I'm going to tack that one there. I don't know why I wrote a 4 there. Address 4 actually contained 11. Okay, add those two things and store them into R3. Now what's 10 plus 11? It's 21. Okay, now write R3 back out to address 3. So we're going to come over here, and what used to be in address 3 is that number. We're going to put our new number there. Okay, and then another clock tick goes, and so he executes this command, which is jump back to P0. And nothing is actually jumping. It's just that this thing that holds what the next instruction was, P2, P3, P4, is set so that the next instruction that's going to run is P0 again. So the clock pulse comes down. He goes, okay, well, I know what my next instruction is. It's P0. Read A3 into R1. All right. Well, now R3's got a different value. So it puts a 21 there. Read A4 into R2. It does that. 11 goes into R2. Add R1 and R2, store into R3. Well, 21 plus 11 is 32. Write what's in R3 back out to memory in this position. So what was 21 becomes 32. Each time, this little counter here telling us what step we're on, you know, P1, P2, P3, P4, now we're ready to execute P4. It's just a jump back to P0, so it updates that next instruction location. And so it executes P0, which reads A3 back in. Now that puts that. So these are registers. This is RAM. This is your program store. Now, in modern computers, your program store is actually part of RAM, right? They're stored in the same memory. It didn't have to be that way. And in some old computers, the memory that held your program was in a different physical device or a different set of memory than your storage. Really olden days. Well, let's do just a little bit of Googling here. I want to show you some things. Like 1940s computers. That's too new. That's not the one that I'm thinking of. There was an older computer. All right. That's still not the one that I'm looking for. I cannot believe that my brain is not remembering the name of the most famous old computer. If it wasn't UNIVAC, what was it? For Pete's sake. Okay, ENIAC. That's the one I was trying to remember. Okay, here we go. Here we go. Here we've got... Really, you're not going to let me display big picture? What's going on here? We have something. Yeah, you can't see a darn thing. Sorry, guys. That's a better picture. All right. Here we go. Look at this. Look at this mess. This was actually the programming instructions. This was the stuff that I had on this side of the screen. And then somewhere else, there was vacuum tubes that was holding this information. Now, what is a vacuum tube? It's just a light bulb, right? That when it's lit up, indicates that it's got some kind of data in it, and when it's dark, it's all zeros. Now, a vacuum tube could have more than just on, off. Maybe it had 10 different stages of brightness, right? Something like that. Even before vacuum tubes, they had mechanical relays where you could have, you know, a piece of machine that could be set to like 10 different values or whatever. But you had that stuff, you had your vacuum tubes, and you had your programming. You wrote your programs just by plugging in wires to indicate commands. And then you would run it, and it would process the data by reading and writing stuff using vacuum tubes. And that was one solution. Are vacuum tubes incredibly reliable? No. And if you have something that has 10,000 vacuum tubes on it, are you spending half of your life running around trying to figure out which one failed because you're not getting the right answers? Yes, that is true. So other kinds of memory were attempted to be invented. This one's kind of fun. These were things that were up to the size of a washing machine, which had just spinning magnetic media in it, just like the stuff that's in a hard drive. But this was also your RAM. What would happen is that when you needed to read a number, this thing was spinning constantly, right? And then if you needed to read, you know, memory address 27, then it would wait until memory address 27 was there, and then it would load that up into some temporary memory like that register. And so you were writing and you were reading to this big magnetic platter that was spinning the whole time. And you can imagine that was incredibly slow, right? All of this stuff is really slow. But so we had our, I wasn't there. You had your computer programming. You have your memory in which all those calculations are done. And it was an important point in time when they combined the two. Why? Because you don't want to have to rewire your entire computer every time you want to run a new program, right? You remember the picture I had of, you know, the people there with all the telephone cables right there? By the way, she's probably the programmer, and he's probably the engineer. The way these things were done is that, you know, you had these electrical engineers who would create these devices, but then it was up to these, you know, grad students and, you know, professor of mathematics and stuff like that were hired, you know, from MIT and Harvard and stuff like that. And so a lot of women were drafted into this process, and there were more female programmers than there were male programmers. And they practically invented all the first programming languages. A woman named Grace Hopper invented COBOL, for example, and a couple of other the earliest programming languages. So anyways, if you wanted to write a new program, would you want to have to pull out and plug in and pull out all those wires? No, you would not. You would instead want it to be just stored in the vacuum tubes. But you had to have a way of getting that data in the vacuum tubes in the first place. That's what those punch cards were for. You'd have a stack of punch cards, and you'd drop them into the punch card reader, and it would read them all in to the memory addresses, and then you could run that program. Okay, so that's all that a computer is it's a little thing in a box, obeying instructions, obeying opcodes, which are just commands to modify stuff in memory. And when it needs to communicate to a video card to display something, it communicates on a different memory channel. If it needs to read in from a hard drive, it is working on a different memory channel. Now that is drastically simplified, but I hope that kind of makes sense. So when we wrote our little program here that did all this, this was loaded into RAM, the compiled version, the executable version of it. And then line by line, it was executed. And when we created variable names, those are pointers to places in memory, right? But we don't have to specify A3, A4, and A5 anymore. Instead, we can give them names, right? Because that's far easier to understand than if you just had to put in numbers, to specify where you're reading and writing. Here's an example of a read, right? Because we're coming out of memory and we're putting it on screen. So whatever was stored at that location has to be retrieved and sent to the screen. Here, this is an example of a write. The user has typed in something that needs to be stored into RAM. And so, whatever memory address is associated with that variable, something is written out to it. Why do I have chapter 6 open? So, your main memory. Every byte in memory is identified by a unique number known as an address. We don't have to worry about the addresses too much because the complexity of handling memory is masked. We use these programming languages so we don't have to know the specific addresses. We just want to be able to use names, right? I want a variable called X and it needs to hold a number. I don't care what memory address it's stored at. So here we have an example of main memory, and one byte has the value of 149 in it, and another byte has a value of 72 in it. Now in real life, the rest of them also have values, right? But maybe they're all zeros, who knows? So non-volatile is data that is retained when the program is not running or the computer is turned off. Your flash memory. We know what an input device is. Software is stuff that runs on your computer, right? But there's different categories of it. You have operating systems, right? You buy the Windows operating system, but it also comes with utility programs and software development tools, perhaps. So operating systems, utility programs are things like you might use to manage your hard drive, and software development tools. And then there are applications that provide services to the user. Your word processing, your games, your internet browser. And practically the internet browser is the main reason that we use computers anymore. That's not true for the gamers. So programs and programming languages. What is a program? It's a set of instructions that the computer follows to perform a task. Our little program here was 5 statements long. We start with an algorithm, which is a set of well-defined steps. We could write this thing out in the form of an algorithm, a series of steps. Now, I actually pretty much did, because I didn't invent opcodes for every one of these things and write them down in some little fashion that was just represented by a series of numbers, right? But that's really all that a computer understands is a series of numbers. So opcode 1, that was reading from this address into register this, would have just been represented by a series of numbers. And then opcode 2 would have been a different number, and all of that information about writing or reading from this register to this address would have just also been expressed in pure numbers. So the algorithm is a defined set of steps for the program to follow. We want to calculate the value of pi. There's an algorithm for that. Algorithm for calculating gross pay. Here's what we want. Just like pseudocode in fundamentals of programming. Display a message on the screen asking how many hours did you work. Wait for the user to enter the number of hours worked. Once the user enters a number, stored in memory. Now this is a little bit more detailed than, Display a message on the screen asking how much do you get paid per hour. Wait for the user to enter an hourly pay rate. Once the user enters it, store that into memory in a different location. Didn't mention that. Multiply the number of hours by the amount per hour and store the result in memory. Then display a message on the screen that tells the amount of money. The message must include the result of the calculation of step 5. Okay, now that's a very wordy algorithm. We could boil it down, now that we already know stuff about programming from our prior classes, to just things like input hours worked, input pay rate, wage equals pay rate times hours, output wage, right? We could express that in pseudocode in 5 lines of very short, terse terms, and we could take that pseudocode and we could turn it into a programming language like C++. So, although the previous algorithm defines the steps for calculating the gross pay, it's not ready to be executed on the computer. The computer only executes machine language instructions, which are just series of numbers that are stored in memory. The machine language, that's the language of things that are fed to the chip in order, the processor, in order to get it to do things. Well, they're just binary numbers, zeros and ones. But we don't want to write our code in zeros and ones. We don't want to be wiggling those telephone cables from port to port in order to be setting things to zeros and ones. So we use programming languages. Low-level programming language could be written in direct binary machine code, all zeros and ones, or you can have a slightly, intermediate version of a low-level programming language, assembly, and it looks like this. Every chip, every operating system, everything has its own version of assembler. Let's see if we can find a good example. Alright, so this is what assembler looks like. Kind of looks like our opcodes. Move something into something. Compare these two values. Add 1 to this thing. Compare those things. If they're equal, jump to this instruction. Else, jump to this instruction. Right? So these correspond to opcodes, but they're at least given English, names rather than just, a move being opcode 32 and then, compare being opcode 64, whatever, just being expressed purely as numbers. But this is hard as heck to read. That's why assembly, everybody documents every single line of code. The source code for the lunar landing computers, that were used, for the moon missions. NASA has published them. They're written in assembler, so there are many, many, many pages of stuff that look kind of like this. And nowadays, your watch is, millions of times more complicated than the computers that ran, the moon missions. So that's assembler, but we don't want to do that. That's annoyingly difficult. We instead want to be able to express our code in the form of stuff like, where's my Visual Studio? Right here. Like this, right? We want an English-like. This is what's known as a high-level programming language, as opposed to assembler. Assembler is the tool that takes that assembly and like code and turns it into zeros and ones, or stuff that could be, executed, known as object code. Anyways, we want to be able to do this. We want to be able to use a high-level programming language. Now, that's not pseudocode. It is a very specific syntax, whereas pseudocode is loosey-goosey. But it's got algebraic notation. So you can say A is equal to B plus C, rather than doing all that business about loading something from memory address this and to register that. Lots of different languages. So from a high-level program to an executable file, you create your programming file, your source code file, with a text editor. Now we could just use Notepad, but we're taking advantage of a nice IDE, integrated development environment. You run the preprocessor to convert the source file to source code program statements. Now what does a preprocessor do? We had 2 or so preprocessor commands. The preprocessor commands are the ones that begin with the pound signs, hash, include, whatever. What that does is it goes and temporarily inserts the contents of that file into this one. And this one temporarily inserts the contents of that file into this one. Now when I say temporarily, it's not like this code is changed. It doesn't go out to the hard disk and save a modified version of it. But in memory, when you run the preprocessor, it opens that file, starts reading it in, it opens that file, it reads it in, and then it appends the rest of this stuff to it. That's called the preprocessor, and it's not a step that Java has. Java doesn't have preprocessor commands. Neither does Python, to my understanding. Then it has a whole chunk of source code that it can compile. So that's the next step. You run the preprocessor, you don't. It happens automatically when we click on the build button. Run the compiler, which converts the source code program into machine instructions, also known as object code. Just all those numbers that are going to be saved to the disk or loaded into memory in order to run. Then you run the linker that hooks all that object code together hardware-specific code to machine instructions to produce an executable file. Now, when we programmed in Python or Java, it didn't do it this way. Instead, we ran a text file. Well, not in Java, but in Python. We ran a text file through an interpreter. And ultimately, in Java, it works the same way. It's just that it's a two-step process. There's a compiler that creates an intermediate file, and then that intermediate file is interpreted. But interpreted means that that conversion is done at runtime. When you run your Python program, it is converted into machine language right there and on the spot. But that's not what happens here. This is converted into machine language when we do rebuild solution, and it runs the compilers and it runs the linkers and it creates an executable file. Now we have an executable file. We could actually run that. We can run it from the command prompt. We could double click on it. Let's go, I'm going to switch this so that it's no longer compiling in debug mode but release mode. So where it says debug, I'm going to change that to release, and I'm going to rebuild the solution. And then I'm going to view my Solution Explorer so that I can come over here and right click on where it says solution, and I can say open folder in File Explorer. I'm going to go find my exe, which is in the release folder because I compiled it for release. And there's my executable. And so I run it. What do you know? Lo and behold, please enter your first name. Joe, Bob. All right, hello, Joe, Bob. So I did all that. I got the executable for it. That executable is composed of the machine language, which was the object code that was linked together. So it's a several-step process. And we don't do enough of this. I'm doing it in my C class that I teach right before this one, which is where we run the compilers by hand, and then we run the linkers by hand and do all that stuff. All of that happens automagically via the benefit of having a development environment like this. We don't know that all of that is happening, and really ultimately we should. That's what that slide is designed for. So it runs the linker, it makes the exe, and then steps B through D are often performed by a single command or a single click. If there are any errors detected at any step, it will prevent the rest of them from running. Right? So if you run the compiler but there's a syntax error in it, it can't make the object files. And since there are no object files, it can't run the linker to make the executable. Okay, just a picture form of the same thing. In case pictures are easy to interpret. You have your source code, what you entered in with a text editor. A preprocessor is run on it which modifies the source code. Those imports are read in, and there are other preprocessor commands besides #include. And then the compiler runs on the modified source code to produce object code. And then the linker turns that object code into an exe file, which is saved out to disk. There are all sorts of IDEs, integrated development environments. This is apparently an old slide because nobody uses Code Warrior anymore, as far as I know. But there is Xcode on the Mac, which replaced Code Warrior for everybody. So Visual Studio, Turbo C++ on your Linux machines and stuff like that. People use a compiler called GCC, and then they will install an IDE that manages the use of GCC, like Eclipse and other ones, so that you don't have to type everything in from the command prompt, but you can. So why do we use an IDE? Because it gives us all these tools in one box. We have this integrated text editor, and we can run it in debug mode, and we can create new files just by right-clicking on things and doing add. IDE integrated. It's all in one box so that we're not having to issue commands into a command prompt. What is a program made of? Sugar and spice and everything nice? It's got keywords. It's got programmer-defined identifiers, which can be variables, class names, and function names. It's got operators, like addition and subtraction and arrow and things like that. It's got punctuation. What's the punctuation? The parentheses and the semicolons. And it's got a syntax, which ties it all together. So here is our source code for the program that we wrote earlier, except we didn't write it. I should have done that. I should have made us go and actually enter code to perform this algorithm that we have up here. And we're going to go ahead and do that. We're going to scroll back up to this thing about pay. All right. I'm going to tack all this stuff above the inner first name and inner last name business so that we don't have to enter those questions every time we want to test this part of it. So my algorithm, display a message on the screen asking how many hours did you work, wait for the user to enter it. Okay, so up above this thing, right underneath the int main statement, let's declare two variables that will hold our data for the number of hours worked and our hourly wage. So I'm going to make them of type float so that they can hold floating point values. In this language, you have to declare every variable. You didn't have to do that in Python. And declare means you have to give it a type. So float hours, comma, rate, hourly pay rate. Now we could give them default values if we wanted to. We could say hours is equal to 0, comma, rate is equal to 0. We don't have to do that because we're going to let the user type in those values. So this is a necessary pre-step for our algorithm. And then our algorithm says, display a message, how many hours did you work? Okay, so cout, how many hours, question mark, space, semicolon. I didn't put a slash in here because I want to let them type in on the same line as the prompt. That's just a choice that you can always make. So we display the message, and the next step in the algorithm is let them type it in. So CIN, arrow, arrow, hours. The other arrows. Greater than, greater than. Do the same thing for the pay rate. Cout, less than, quote, pay rate, question mark, space, end quote, semicolon. CIN, arrow, arrow, rate. So we're using keywords, that is a keyword, float. We're using identifiers, which are these variables. We're using operators. Right now the only operators we're using are the arrows. We're using punctuation, which is the semicolons and the commas. All right, now we need to multiply those things together. I believe that was the next step. Multiply the number of hours by the amount paid per hour and store the result in memory. Okay, so let's declare one more variable called salary. And then salary equal hours times rate. Now we need to display a message telling the user their salary. Cout, arrow, arrow, quote, your salary is $, end quote, arrow, arrow, salary, arrow, arrow, E and DL. That's an L, not a 1. And if I didn't like typing E and DL, I could replace that with quote, \n, end quote. Whichever you find easier to type. You like typing in E and DL, that's great. You like typing in quote, \n. I'm going to type in E and DL. My general rules is if I'm already in a string and I can just type in /n before my final quote, I will use /n. Otherwise, I will use E and DL rather than open up a new quote. All right, and then let's pause. If you're on Windows, why not just pause here? Well, except that's not how you pause. System, quote, pause. I'm just doing that to distinguish it from the other code that we wrote. All right, so that's my code from there to there, underneath int main. All right, how many hours? Why is my text so small? I thought I fixed this. All right, I work 40 hours a week. Your pay rate, make $13 an hour. Your salary is $520. we could expand upon that. We could say 520 a week. We could do some special formatting to make sure that it displays only 2 decimal points, .00, that kind of thing. But we have followed the algorithm to write some code to produce a solution that does what they asked. Anybody got syntax errors that y'all would like help with? In a small class, we're going to make faster progress than, if there are 30 students in a class. It takes a lot longer to wander around making sure everybody's got it going. That's pretty cool. On the other hand, this class was almost so small that it almost got canceled, so this is the perfect size in my opinion. Nobody dropped the course. Okay. Yeah. Okay, so keywords, programmer-defined identifiers, etc. Here's our code, sort of. Here's a keyword. It's actually a type, data type. Here's another keyword, cout. Another keyword, cn. Not very many keywords. Return. Using. Then there are preprocessor directives, the things that begin with $. You could almost call them keywords. Then we have our identifiers. The identifiers are the things that we got to choose. And the identifiers are meaningless to the computer. They're very important to us. Did I have to call this hours? No, I could have just called it H. If I called it H, then I'd have to, oh come on, unshift it. Okay, fine, capital H, right? I'd have to change everywhere where that occurred in order to get that to work. But I could do that, there, right? The program works just as well. I could call it something stupid, like, Stark. All right, and as long as I fix every occurrence of that variable, the program's going to work just as well. So your identifiers can be anything, but they should be meaningful, right? And hours is a good variable name because at least it indicates what kind of day, or it tells you some purpose. A single letter variable name doesn't tell you much, right? If I just had H, that's kind of harder to figure out. But if we see hours and rate there, then we can kind of figure that out. We could give even longer variable names, but then they become harder to type, so I shy away from them when I'm working up here. But when you're creating your own code, use variable names that are as long as they have to be in order to make sense. Like patient temperature, you could just call that PT, right? Patient temperature, PT, or even worse, just T. But it's better if you actually have the words patient temp, right? Something like that. So pick meaningful identifier names, but they are just for us. The computer doesn't care whether we call that hours or something stupid like that. As long as we put that in every single place that it needed it, it would work just as well. Hope that makes sense. I think I deleted something. Better undo all that. All right. So keywords, also known as reserved words. What does that mean? They're reserved. I cannot create a variable called system. That would be an error. If I tried to create a variable, I'm going to make a floating point variable called system. That's an error because this is it's not calling it an error. Let's rebuild it and see if it calls it an error then. You better. Well, it's a function call rather than a keyword, so that's a bad example. The keywords are the things that are defined in blue. So if I tried to create a variable called int, that wouldn't work because that's a keyword. You can't create a variable called int. If I tried to create a keyword called return, I forgot to put a return statement at the bottom of my code, and I should. The very last thing in our code, scroll down to the very bottom, should be return 0. And some compilers would have flagged that as an error. Microsoft is playing loosey-goosey. and not making us do that return 0. Why does it have to return something? Because our main method, our main function, was defined as being a type int, meaning it returns a value. Well, where does it return that value to? It returns it to the operating system. Do you remember when I was running the executable by double-clicking there? When you run a program and it has a return, that number gets fed back to the operating system, and the thing that called the program could check that return code. A typical thing is to say that if something returns a 0, it's succeeded. And if it returns a non-zero value, it's an error. Now, why doesn't Java have return out of int? Because it's not called by the operating system. The operating system does not launch the Java executables. Instead, they're launched by Java itself. And so they decided that there weren't going to be any return values for your main method, by your main function. But there certainly is in C and C++. All right, so reserved words are words that you cannot use for your identifiers. You can tell really fast if that's the case, because if you type it, it'll flag it as an error immediately, right? Int using. I wanted to create, for some ungodly reason, a variable called using. That's an error. If I hover my cursor over it, it says expected an identifier. Now that doesn't tell us exactly what the problem is, which is that we used a reserved word, but hopefully we can figure it out. Oh, well, that should have been a variable name, and this is an illegal variable name. There are, about 40 or 60 reserved words in the C++ language. Programmer-defined identifiers. These are the names made up by the programmer, the variable names and the function names. Not that we've created our own function except for the main, but main is also an identifier. We could change this. The program would no longer run, but it would compile, right? Why wouldn't it run? Because every C program, every C++ program has to have a main method that gets launched. And if there's nothing called main, it can't launch it. So your identifiers are not part of the C++ language. You're making them up. They're used to represent various things. Variables, which are memory locations, functions, class names, structure names. In Program 1.1, hours, rate, and pay, or whatever we call them, hours, rate, and salary, I think, are variables, which are identifiers. And there are rules to what you can call a variable. And they're very similar to the ones that you've used in Java and Python. You can't start a variable with a number, and they are case sensitive. So when I was creating my program and I said that variable names don't matter, well, they do matter a little bit. I can't start one with a number, right? That's one rule. Another rule is that there can't be a space in your variable name, because then it thinks that it's two different tokens rather than just one. They are case sensitive. So if I type in lowercase h there, but I type in an uppercase H there, those are considered two completely different identifiers, and so it will no longer compile. You could just make up the rule that I'm going to make everything lowercase, right? But there are other ways of creating variables where you do mixed case, lowercase, and uppercase, or you use underscores, things like that. Back in olden days, there were programming languages that said that if something was defined in uppercase letters, it was a variable, and if it was a lowercase letters, it was not a variable. And that's how it distinguished between identifiers and program code. That's kind of silly. That's ancient history. Let's go back here. And then the operators. When we multiplied our data, we use the multiplication operator. When we stored that back into our variable so that it could be printed out, we use the assignment operator. And then we also use the stream insertion operators in order to get data into the variables or to send it back out to the console. Punctuation, characters that mark the end of a statement or separate the items in a list. So that's punctuation. That's punctuation. Also, I would consider these things as punctuation as well, although they didn't. Right? Because they're not keywords. They're not operators. I consider them punctuation. So what is syntax? That's the rules that must be followed when writing a program that controls the use of the keywords, the operators. A good example of syntax is if we have this statement, hours is equal to 40. We're going to assume that they worked 40 hours. That's good syntax if I not messed it up. But what if I did this? 40 is equal to hours. That's not good syntax. The variable has to be on the left-hand side, and the expression that is calculated to store the variable has to be on the right-hand side. That's just part of the syntax. Whoever invented the language said that. It's a reasonable syntax, and just about every programming language follows it. But that's why this doesn't work. Or later on, when we were doing that multiplication, we did salary is equal to hours times rate. We could have typed in hours times rate is equal to salary. No, we couldn't. That's a syntax error. Syntax dictates that the assignment operator has to have a variable on the left-hand side and an expression on the right-hand side. And that doesn't work here, because on the left-hand side of the equal sign is an expression, and on the right-hand side is a variable. So that's bad syntax. So what is a variable? It's a named storage location. I don't want to just say address 1, address 2, address 3, address 4. I want to be able to make up a nice, convenient user, human readable name, and then let the compiler and the linker figure out what memory address it's stored in. So a variable actually has several pieces of important data, which is not quite mentioned here yet. And we're going to mention it here, and then we're going to keep saying it over and over and over as class goes on. A variable has several components. It's got an identifier, also the name. I will probably just call it the name from now on. It's got a type, whether something is a string like our names were, whether it's a number, floating point number. There are other data types. When we used Python, we had like 3 types that we cared about: ints, floats, and strings. C++ has like 30. You'll get a staggering list of them on another slide coming down the pike. Why so many? Because they have different sizes. Some data types are 2 bytes. Some data types are 4 bytes. Some data types are 8 bytes. And the ones that have larger number of bytes can hold much larger values because you have more bits. The maximum value is larger. Okay, so string and float are possible types. Int is another one, a whole number. And then it's got a value, right? And then it's got a memory address where that value is stored. Now we get to pick all of those things, but we don't get to pick those things. So when I ask you for the attributes of a variable, I don't even care if you say it's got an address, for the most part. But it is strictly correct to say that it's got 4 components. These are the ones that I want you to burn into your brain, and if I asked you to tell me what are the 3 components of a variable, that's what I would mean. It's got a name, it's got a data type, and it's got a value. Now in Python you didn't have to specify the data type, but every variable did have a type. You just didn't have to specify it. But in more strictly typed languages, strictly typed, strongly typed, you do have to give a data. You have to declare your variable, give it a type before you can use it. In Python I could get away with just saying something like, and for those of y'all who jumped into this class without having taken the prereqs and stuff, why are we talking about Python so much? Because that's what the prereq was taught in. So anyways, what if I wanted to call it pay? Pay is equal to hours times rate, just like they did in their example. That's an error. Pay is undefined. I have not declared that variable. I would have to declare it, which means give it a data type. So above that, or on the same line, I could do float pay is equal to hours. There, now we have declared it. The type of a variable cannot change. Once I have created a variable of type float, I cannot turn around and then store a string in it. That's not true of Python. In Python, you can store any kind of data you want into any variable, and it restructures the variable type in order to hold the newest piece of data you gave it. But in a more strictly typed language like C, C++, or Java, That's not true. Once you declare a variable, you can only store data of that type in it. And if you try to store something else in it, it'll be a compiler error, a syntax error. Alrighty, my voice is wearing out. We're supposed to keep going until 10. We might get out just a couple minutes early for our first session. Okay. You'll notice that chapter 1 is pretty short. We're already almost at the end of it. I wonder if we could finish this puppy off by the end of before we go. Let's set that as our goal. So variable definitions, you give a type followed by a variable name. And if you want, you can list multiple variable names. I didn't have to do it the way I did here, right? I did float hours, comma rate. I could have done this, float hours, float rate. That is actually my preferred way of doing it. Why? Because then I could put some comments here that describe them. Hours worked per week. And then rate. You know, pay rate per hour, right? If I list them separately rather than listing them all in one line, listed by, separated by commas, then I can't really do it like this. So this is my preferred style, actually. But you got to admit it was easier just to type float hours, comma rate, right? So that's why these examples do that. Takes up less screen real estate if you put it, you know, all in one line. They defined all three of their variables. In some languages, you had to declare all your variables up at the very top of your function. We didn't have to do that. We kind of created them on the fly, right? We created float and hours and then rate, and later on we had one called salary, and then we had one called first name and last name. Back in old days, you would have had to do all that up at the top of the program. Float salary, string first name, string last name. There is nothing wrong with doing it that way. There's nothing wrong with creating all your variables in advance. Now it ought to be giving me an error of that I am recreating them later on, but I forget if the C compiler is more generous than that. But you know, I would delete all those declarations. Okay, now we declare all of our variables up at the top of your function. You can do that if you like it. If it's not a bad idea to declare your variables up top. On the other hand, something could be said about for declaring them right before you're going to use them, right? Because if I do this, CIN into fname, I don't really know what fname is. Yeah, I could figure out it's a string by looking at the statement before, but if I want to figure out what it is, I'm going to have to go up here and find it. Now, fortunately, there are tools that make that easier to do. If I highlight the name and right-click on it and do go to definition, it'll take me to the line that defines that. So there are many different types of data types, and you can create your own data types. You're not just limited to ints and floats and doubles and strings and stuff. So a variable holds a specific type of data, and a variable holds one value. And if you put another value into it, the old value is lost. Just like when I did my write to the memory, it erased the old number that was in it. That variable no longer has that data in it. So a variable definition specifies the type of data the variable can hold and the variable name, and when you define it, you can also initialize it with the data at the same time, but you don't have to, in which case it's a so-called uninitialized variable. Let's give an example of an uninitialized variable. This is uninitialized. They're all uninitialized at this point, but that means that I can't really do much with them, right? If I did salary is equal to hours times rate, that's not really good news there. There are build errors. Uninitialized variable used. Why is that an error? Because we never gave hours a value. It's uninitialized. We never gave rate a value. If we wanted to, we could do equals 0 up here just to prevent that kind of message. But it's a logical error as well, right? Because we don't need to calculate the salary before we know what they are. But yeah, this would make the error go away, right? It would compile now, but it's going to, you know, salary is going to be calculated as 0. So One rule of thumb is that just initialize everything. Another is don't initialize anything unless it absolutely has to be done, because you don't want invalid data in there. And that just kind of masks the problem. What do I mean invalid data? Hours being 0 and rate being 0. I cannot perform that calculation. This statement should be further down after they have typed in the hours and the rate. A common programming problem, or a little paradigm thing, usually I see it in the fundamentals class and not in this one, is once people think that if they type that, it's going to be generically true, right? You could put that here, and then later on, when hours changes, salary is going to change automatically. And then when the rate changes, the salary is going to change. Like this is somehow getting updated automatically every time these things change. That's not true. The code just runs consecutively. It runs in sequential. It's not going to magically run up here. Redo this statement just because somebody changed the value of hours. But people think, well, I'm going to define my formula and put it in the code and that ought to work. No, and if you want to think that way, what you got to do is you got to define this as a function that you could invoke every time you wanted to calculate the salary. All right, I'm taking this back out because I don't want to upload our notes with something as obnoxious as that. Okay. So, the word double specifies that the variable can hold double precision floating point numbers, which we will learn about. Remember I said that different data types can hold different number of bytes? There are 4 byte values, and then there are 8 byte floating point numbers. 4 byte floating point numbers can hold large numbers, but 8 byte floating point numbers can hold much larger ones and much more precise, the decimal points that go out to, 16 different, numbers instead of just 8 or whatever. So, the word float, which I use, uses a smaller type, the 4 byte values. The word double holds the 8 byte types. All that it means is how large and how precise of a number that can hold. Input, processing, and output. Our programs generally are going to run in this process. They're going to gather some input, whether the user types it in or from the files on the disk drive. It's going to process the input data and it's going to display the results as output. Now, these steps are going to be intermixed sometimes. Processing input data. What if the first input is open a file, right? And so we need to ask for the file name. Okay, that's some input, and then we're going to process that. How are we going to process it? By opening the file, and then there's going to be more gathering of data, right? As we open that file and we run through it. And we're going to be displaying results the whole time. But in general, especially at the beginning, this is going to be the general sequence of stuff. We'll get some input data. We will process that data via some formula or whatever, and then we will display the results. The programming process, the Zen of program maintenance. Define what the program is going to do. I'm going to give you some instructions, that for an assignment or whatever. Visualize the program running on the computer. I like that one. Be the computer. Okay. Use design tools such as hierarchy charts, flow charts, or pseudocode to create a model of the program. Now, we sure don't actually do these things in this class. We did in 113. Check the model for logical errors. Now, here's what people really do. They leap from step 1 to step 5, right? But, you have these tools at your disposal that you've learned in prior classes about logical thinking. And the larger the project, the more important it is to plan it out in ahead. Yeah, if I'm going to write a program that calculates somebody pay and overtime, I could do it in my sleep, and so I'm not going to plot it out first. But if you're having problems getting this stuff to work and you need to figure out the order in which these things work, you use these ideas, flow charts. Or, since flow charts are hard to draw, at least a pseudocode. Just map out the algorithm, the recipe that your program has to follow before you actually start trying to turn it into C++ code. So, you type the code, save it, compile it, and then if the errors are found during compilation, you fix them. You keep doing that over and over until it has no build errors. Then you run the program with test data. You may spot errors, in which case you jump back to step 5 again. It's just kind of cyclical, right? You do 5 and 6 over and over until there are no compilation errors. Then you find some Logical errors is producing the wrong output, and so you correct them, you keep making changes, and then you keep testing it with test data until it totally works. You validate the results of the program. I'm going to skip this slide completely. All right, gang, check it out. We finished an entire chapter at one time. I'm not going to quiz y'all on chapter 1. I'm not going to assign a quiz for that. But do read it, you know. Get your book, read that. But the real programming of the class starts in chapter 2. This was just sample code to get it locked into your brain, you know, so that we had something to look at, get familiar with the tools. So what is your homework? Your homework is to install Visual Studio or another programming tool, or to tell me that you're going to do your homework here, right? Those are really your choices. Install a compiler, or say that you're going to do your homework here. And if you change your mind, you can do that as well. So I'll make a Dropbox for that with the instructions for installing Visual Studio. But we also need a Dropbox for our daily homework, our daily in-class stuff that we just typed in. So let's make that Dropbox. I have to do it. So in class A is first homework. I'm going to take the words in class out and make that the submission folder. In class. Okay. All right, guys, there we go. Go to our D2L, go to the assignments folder, click on the Dropbox there, select the file, and submit it. What file? You just need the CPP. So what I would do is I would go to my Solution Explorer. This is the easiest way for me to find it. I would right-click on the solution name and choose Open Folder in File Explorer. And then boom, here's my project directory. And the CPP file itself is stored in the project folder that has the name of the project. So I double click on that and I can find my CPP file. If you do not see those extensions, it's pretty important that you do see those extensions. How do you do that? Well, it depends on which version of Windows or whatever, but you go to Organize, Folder and Search Options, View, and then deselect the Hide Extensions for known file types. So on your computer at home, it may not be configured to show the extensions. You will want to do that. If you can't figure it out, just Google up, Windows 10 display file extensions, and it'll show you a series of steps. All right, so that's the file that I'm going to upload. I would then go into D2L, find my assignment, drag the file over. That's what I would do. Add a file. Drag the file over. Ta-da. Upload it and submit it. Alright guys, so your first homework assignment will be to install your compiler. That's going to be due Sunday. I'd get it done earlier so that when the homework assignment from Wednesday comes around, then you'll be able to jump on it right away. Alrighty, are there any questions? I don't ask that often enough. I ought to lecture for like 5 minutes and then stop and wander around. I don't remember to do that. So, do you store up any questions? Well, we're going to get out a whole 15 minutes early. Maybe even a little more. All right. Hope you're interested. Hope nobody's going to drop the class. Hope that what we did made sense. Read the chapter and it'll make more sense still. And a lot of these concepts are stuff that's carried over from other. But then again, hopefully we're mixing in new stuff at the same time. All right, I'll see y'all Wednesday. Did I forget to take roll? Why, yes, I did. Well, take it based on what's uploaded.
Where's the download link for Visual? Say what? Where's the link? Where does it on?